There are so many advocacies for unity. As the disadvantages of disunity continue to bite hard on the general society, notable figures like Kwame Nkrumah of Ghana, Haile Selassie of Ethiopia, and Thomas Sankara of Burkina Faso advocated for unity. Some vectors may also be seen as advocates of unity. They are called unit vectors. A unit vector is a vector whose magnitude is equal to unity, which is equal to 1. For example, the vector C equal to bracket open 5/13 above 12/13 bracket close is a unit vector. We will verify if C is a unit vector by finding its magnitude. The magnitude of C is equal to square root of bracket open 5/13 bracket close squared plus bracket open 12/13 bracket close squared. Solving further, we have square root of 25/169 plus 144/169. The terms in the square root sum up to give 169/169, which is equal to 1. Therefore, the magnitude of C is equal to the square root of 1, which is equal to 1. Unit vectors are usually written with a circumflex or heart-like symbol above the letter or letters denoting the vector. So, we can rewrite the unit vector C with a circumflex or heart above it. There are unit vectors that lie in the positive directions of both x and y axes respectively. The unit vector in the direction of the x-axis is written as bracket open 1 above 0 bracket close, and the unit vector in the direction of the y-axis is written as 0 above 1 in brackets. The unit vectors for the x and y-axis are denoted by I and j respectively. They are also called base vectors. Since the unit vector has a magnitude of 1, the length of the vector is always 1. Vectors can be written in terms of their unit vectors. For instance, if we have a position vector G at a point 2, 3, the column vector for G is equal to bracket open 2 above 3 bracket close. This column vector is still equal to bracket open 2 above 0 bracket close plus bracket open 0 above 3 bracket close. If we bring the scalars out of the brackets, we have that the position vector G is equal to 2 bracket open 1 above 0 bracket close plus 3 bracket open 0 above 1 bracket close. Now, the column vectors correspond to the base vectors I and j. Therefore, the position vector G is equal to 2i plus 3j. Generally, any column vector can be expressed in terms of the base vectors I and j. So, if we have a column vector P equal to bracket open x above y bracket close, this can be written as x bracket open 1 above 0 bracket close plus y bracket open 0 above 1 bracket close. This in turn is the same as vector P equals xi plus yj. Can you write the vector V with horizontal and vertical components 5 and 7 respectively in terms of the base vectors? Of course, V will be equal to 5i plus 7j. We can go on and on, but let's draw the curtains here. Before I go, let's summarize. We have learned that a unit vector is a vector that has its magnitude as 1. Also, the unit vectors in the positive direction of the horizontal and vertical axes are called base vectors I and j. Finally, we can write vectors in terms of the base vectors I and j. Do you wish to know how to get unit vectors that are in the same direction with a vector? Stick around.